Hello, I am Gizem Mesci. I am the fourth year student in Electrical and Electronics Engineering Department in METU. First, I want to give an answer to the first question in the Laboratory 1 experiment video. In the experiment procedure part 1, it was found that the number of turns is equal to this value. It is known that the cross-section area of the conductor is this. And the window area of toroidal core is equals to this value. Let's draw the toroidal core. These are the cross sections of turns of copper cable. When we multiply this cross-sectional area with the number of turns, we get this value. In practice, actually in real life, this total area cannot be larger than this window area. This is the total area and this is the window area, because this area, this window area, is our limitation. Hence, the fill factor calculated for this question, which was 144%, is not possible to obtain in practice. Okay, let's move on to the second question. In the experiment procedure part 2, for the inductor with 600 microhenries, number of turns were calculated and it was 14.7. But the value of n should be integer, therefore actually it was taken as 15. So in the experiment procedure part 3, the inductor was winded with 15 turns and the corresponding inductance value was measured as 608 microhenries in RLC meter. Actually, this value is slightly larger than the value that we had in part 2. This difference is because of our assumption. We assume that n is not this value, but it is the nearest integer value, 15. Due to this approximation, the small difference 8 microhenry occurs between our calculation and RLC meter measurement. I think there may be another reason for this difference. While we deriving the expressions, the formulas for the basic magnetic quantities, we made some assumptions. One of these assumptions is that we ignore the leakage flux. So far, we only considered the effect of magnetizing flux. However, in RLC meter measurement, the effect of the flux leakage can be observed on the measured values. For example, phi t, the total flux, equals the leakage flux plus the magnetizing flux. And we know that the flux linkage equals to inductance multiplied with the exciting current, and actually this equals n phi, and then it can be clearly seen that the inductance value is dependent on the phi value. As a result, in RLC meter, since there is no assumption such that the leakage flux is ignored, the measured inductance value will possibly be slightly different than our calculation. Okay, let's move on to the third question. In this part, we had two inductors designed by using the same toroidal cores, and the windings of these two inductors had the same number of turns, which was 15. We know that the inductance of one of them was measured in RLC meter as 608 microhenries. We know this result from the previous parts. However, when we connected the second inductor to the RLC meter, we got a different measurement, which was 675 microhenries. The toroidal core is the same, the winding is the same, then where does this difference come from? I think this difference arises because of the production of the core related reasons. When we look at the electrical properties of the core, which was used in this experiment, we can see this is inductance factor. This is the error, actually error of this toroidal core, plus minus 25%. This is the inductance factor, this is the error. So I think this explains the reason why we measured different inductance values even though we used the same cores and windings. Let's move on to the last question. In the experiment procedure part 7, we winded another cable around the toroid in series with the other winding and in the reverse direction. Let's draw this. Okay, this is positive end, this is positive end. L1 is the self-inductance of the inductor 1 and L2 is the self-inductors of the inductor 2. And L equivalent, the equivalent inductance can be written by this formula. Here M is the mutual inductance, but why this is a negative sign? Why there is a negative sign here? Because of the reverse connection, the directions of the fluxes flowing through the magnetic core of these inductors are in different directions. Actually, they oppose each other. We know that L1 equals M1 square over the reluctance of a core, L2 equals this, and M equals mutual inductance equals this. And we know that N1 equals N2 equals 15. Let's say this, N. Then we can write the equivalent inductance as it can be clearly seen that this equals to 0. The equivalent inductance should be 0, but in RLC meter we measured this value. 24.7 microhenries. I think because this is a very small inductance value and it is near to 0, this value and this value and this value are more or less consistent with each other. This difference may arise from the errors in toroidal core we used or the errors in RLC meters. Actually, in real world, nothing is ideal and the assumptions we made by calculating the quantities are not valid in the real world, generally. So I finished to answer the questions in the Laboratory 1 experiment video. Thank you for listening.